In this tutorial, I'll be explaining about the balancing of chemical equation using the algebraic method. We have this HClO4. It's called perchloric acid. P4O10. This is known as phosphorus pentoxide, that is 5-oxide. When these two reactants combine to form phosphoric acid, H3PO4, orthophosphoric acid, and Cl2O7, which is nothing but chlorine heptoxide. Hepta means 7. So chlorine heptoxide. Now let us discuss how to proceed with balancing of the chemical reactions involving these two reactants, that is perchloric acid and phosphorus pentoxide, to give orthophosphoric acid and chlorine heptoxide. Let us consider A moles of HClO4 plus B moles of P4O10 gives C moles of H3PO4 and D moles of Cl2O7. Now let us consider the element hydrogen. And what about the hydrogen? It has A hydrogen. And what about the product? It has 3C hydrogen. Let us identify the element hydrogen first. On the reactant side we have A moles, is it not? So hydrogen, let us identify. So A moles of hydrogen is equivalent to 3 moles of, that is 3C moles of hydrogen. This 3 represents the atomicity and C is the molar coefficient of phosphoric acid. Similarly, the molar coefficient of Cl2O7 is D and the molar coefficient of HClO4 is A, and for phosphorus pentoxide it is B. Now we are just comparing based on the elements. Let us consider, so this is a very important equation, and let me consider the next element, chlorine. So on the left side you have A amount of chlorine plus on the right hand side you have 2D, you have got that atomicity 2 into D. So 2D amount of chlorine in Cl2O7. So this is another equation. And oxygen. How many oxygens are there? 4A oxygen. So let us say 4A oxygen plus, and here 10B oxygen. So 10B oxygen is equal to, on the right hand side you have 4C oxygen plus 7D oxygen, right? And what about phosphorus? Let us have phosphorus also. How many phosphorus are there? 4P on the LHS equal to, on the right hand side you have 1C only, okay, right? So we have to write down all these set of equations based on the elements for each element, right? Now let us consider the first equation. A is equal to 3C. So when A is equal to 3C, Let me consider C is 1. Assume that C is 1. So in that case, A is equal to C into 1 means 3 into 1, that is 3. A is equal to 3. Now you have A and C, and based on that you can find out D also. So we have found out A is equal to 3, so substitute here, that is equal to 2D. Therefore D is equal to 3 by 2. So we have found out D also. And what about B? So A we have, C, D, and leftover is B. And where is B? So 4, here you have 4B. This is 4B. So 4B is equal to, let us consider this, 4B is equal to C. Okay. So I want to find out B. So C is already 1. So 4B is equal to 1. So B is equal to 1 by 4. Now we have the value of A, how much? 3. The value of B, how much? 1 by 4. What is the value of C? 1. What is the value of D? 3 by 2. So based on that we can proceed. Okay, right. Now let me rewrite. The value of A is equal to 3. The value of B is equal to 1 by 4. The value of C is equal to 1. The value of D is equal to 3 by 2. The given equation is A HClO4 plus B P4O10 gives C H3PO4. So these are all A, B, C or molar coefficients, and for which we have found out the value. We have to substitute, and we have D amount of Cl2O7. So let us substitute. So 3 HClO4 plus 1 by 4 P4O10 gives C, that is 1 mole of H3PO4 plus 3 by 2 moles of Cl2O7. So what about this 3, 1 by 4 and 1, then 3 by 2? These are all molar coefficients. So it is understood that this is 1. Okay. Now we need to get that is LCM. Okay. And not only that, we should be able to that is convert this equation into a stoichiometric one, because this is a fraction 1 by 4 and 3 by 2. So we need to convert the entire equation into a stoichiometric equation, that is well proportioned equation. So between 4 and 2 we can find out the LCM, that is 4. Okay. So the entire equation can be multiplied by 4. So in that case, now you have, that is 4 into 3, 12 HClO4 plus 4 into 1 by 4, 1. So P4O10 gives H3PO4 4 times. So 4 into H3PO4 plus 4 into 3 by 2. So 4 into 3 by 2 means 2 2s are 4. So 6. So 6 Cl2O7. Now let us check whether these elements are balanced in this equation. So we have element and LHS, then that is as a reactant, then product. Okay. Now let us have E. So what about hydrogen? Let us take the that is hydrogen, each element, chlorine, phosphorus, oxygen. Now hydrogen on reactant side 12 hydrogen, product side 4 into 3, that is 12. And what about chlorine? 4 into 12. 4 into 1. 12 into 1. Is it not? 12 HCl. So we can have 12 HCl. And what about chlorine on the other side? 6 into 2. What about phosphorus? 4. And here 4. What about oxygen? 12 into 4, 48 plus 10. And here 4 4s are 16 plus, and here 42. So 12 and 4 3s are 12. Right? This is okay, balanced. This is 12, this is also 12, balanced. 4 4, balanced. And what about this? 58. And here is also 58. So everything is balanced. Are you able to follow? So with the help of this algebraic method, you will be easily able to balance any chemical equation. Okay? Right? So what you have to do is put the coefficient A, B, C, D and arrive at the equations for each element and substitute these values here. Okay? So once you are able to substitute, then make it as a stoichiometric equation by taking the LCM. That's it. So this is the balanced chemical equation, and you can check this by E or P method, that is element, reactant, product individually. Okay.